Greetings! In this video, we will be covering the part 8 of CMP 1002 Object-Oriented Programming course. Here we will be focusing about the basic data structures, in particular the vectors, and in relation to the vectors, we'll be covering an iterator of the vector. In order to keep a group of variables in an organized, structured way, what we have been using here, one of the key things that we have been using is actually the basic array stuff. This is how we declare an array using the square brackets, and you can utilize it, you can initialize it either by giving a fixed size, or you can just utilize it with within curly brackets, and then the fixed size will be determined by the number of items inside. And we have been saying that one of the key limitations of the classical array is the fact that you cannot change the size of the array during the program. You cannot increase it, you cannot decrease it. In order to do that, one of the ways that we have been talked about in the previous semester's course is using the malloc realloc system. In this case, using the malloc, if I write it something like this, then I'm gonna be allocating a memory space of 12 integers in the heap, and then in the subsequent lines of the code, I can use the realloc to increase or decrease the size of the array. In this way, I actually have some way of really having a variable, having an array with dynamic sizes. However, the thing is, we are generally, as we have covered the unique pointer and the shared pointer, we really don't want to utilize this basic pointer stuff because you have potential memory leak issues here. So, you might be saying like, okay, we have covered two things now, and in both of these scenarios, one of the we don't want to use it, and one of them is pretty limited in this sense. So what is the solution? Like, what am I gonna use to have an array that have dynamically changing sizes? So the answer, a very, very good answer, is the vector class. A vector class is what the C++ STL, standard template library, calls a container. There are other containers, but vector is one of the containers. Basically, vectors are dynamic arrays with the ability to resize. So they can increase, they can decrease their sizes while the program is running. And even better, they can automatically resize when you insert a new item or when you delete an item. So how do we declare it? You just write down std : vector, and since this is again a template, you open up this and close down less than greater than square brackets couple, and then you write down whatever the type of the items within the vector is. In this scenario, it is gonna be an integer vector, and then you write down the name. You don't even need to write down the size. In this first line, then the C++ will open up an integer vector with no size. I mean, just 0 size. In the second example, I have given this within parentheses a 5. So this next vector, the second vector, is again an integer vector, but then it has an initial size of 5. But don't get me wrong, you can increase or decrease it whenever you want. So how are we gonna add some item within this array, within this vector? We have a special function called pushback. So we just write down array.pushback, and then we just give whatever number, whatever value we want, and then that will be added at the end of the vector. So in the first example, if you say to the array, then the zeroth element, since this is already initially a 0 item vector, so the moment you push back something, then the 0th item will become available and its value is gonna be 45. In the second scenario, in another array, if you say another array.pushback 45, then it's gonna be the 5th item, because there's a 0th, 1st, 2nd, 3rd, 4th item already initialized by the initialization step, and then it's gonna be the 5th item. Whenever you want to remove something from the vector, if you want to remove it from the last, then you have this pop back function. You don't need to specify the value of the function because, come on, I mean, C++ already knows that. So this actually looks like the stack structure. If you remember a couple of weeks ago when we talked about the stack, we said that the stack, you can only add things by adding something at the end, which is called a push. And then when you want to remove something from the stack, you have a special function called pop, which actually returns something from the end. You can use this thing in the vectors, but don't get me wrong, this is not the only way of adding or removing things from the vectors. Vectors are much more powerful and versatile than a stack. We'll come to that. Since one of the good things about the vector is it also utilizes the array notation. So if you just say, like, after declaring an integer vector, if you say array within square brackets a value, an integer value, this is basically saying, like, I want to access the ith item of the vector. If you want to access the same location using a function, then there's a specific function called .at function. And you have to, of course, give an argument, which is the which item that you want to access within the vector. Please note that, again, similar to the array structure, the initial item of the vector is the 0th item, not the first item. Same logic with the array. At least there's a bit of a consistency there. That's really good. Then there's a size function, which is gonna give you the size of the vector, how many elements there are in the vector at that time. This is gonna be quite useful when we will be doing something like a for loop and want to go over all the items starting from 0 till this size. This is gonna be a very, very useful function. And next there is a clean function which deletes all the items in the vector. You do not use this function that much, but it is there. If you don't want to delete things one by one, this is another good option. Okay, let's go over a very simple example. Here it says, write a program that reads an integer n, then reads that many integers and puts them inside an integer vector. Then, finally, it's gonna calculate the average of these numbers over the vector. Okay. So, first I will be declaring this int n, which is gonna be the number of numbers, right? Yep. Then I will be opening up this vector, std : vector less than int greater than. In order to use this function, you have to include this vector library, as you might be imagining. Then, I don't know, let's call it, I don't know, int array. Okay. I don't want to give it an initial size because it's not very necessary for this particular example. Then std::cin, I'm gonna be reading the value of n. Then I am gonna say for int I equals 0, I less than n, I plus plus. Then I want to use a little bit of a temporary variable. Let me call it here CMP. Then within this for loop, I will be reading something, reading the 0th element, first element to the TMP. Then I'm gonna say int array dot push back TMP. Okay, so this is how I read all the items from the user. Then I want to open up another for loop. This time I want it to go from 0 till the size of the vector, which will be the value of n, by the way, but this is another usage, so this is a little bit of an example there. In this, here I want to add up all the values. Add up all the values inside the variable. I just call it double average. Double average, and I want the initial size to be 0, obviously. So here it's gonna be average equals average plus int array up, int array I, as if it is a regular array. So we can use a square bracket notation. At the end of the for loop, I have to calculate the average value because currently the value is just the summation of all the items. So I'm gonna say average equals average divided by, I can either say n, because I know that there are n number of integers there, or I can also say int array dot size. Both of them will give me the same result. Be careful, since the average is already a double value, this is gonna be a floating point division, a real division, so I don't have to do any typecasting stuff here. Finally, I'm gonna say the average of the items within the vector is average. Okay, let's run it. Let's say n is 5. I have several numbers. I can also give it negative numbers. Okay, 45, 51, 58, 53, 90, 62, 62 divided by 5. Yeah, 12.4. Okay, so I just utilize the vector. I just initialize it as empty. And then I read as many items as the value of n. And individually, I call the pushback function for every single one of these values so that I pushed them to the array. Then I go over the array one more time, but this time I'm gonna go from 0 to the size of the array. It's just a bit for, utilizing the size function, don't get me wrong. And then I just called the ith element of int array using the square bracket notation as if this is a classical array. Finally, the average function is called, and then the average value has been printed out. Not so difficult, honestly. It is very similar to the classical array usage, right? Okay. Another example. Here it says write a program that declares an int vector. Okay. Then the program keeps asking for numbers from the user to put inside the vector until a negative number is entered. Alright, so there's gonna be a while loop here, not a for loop. Then, finally, the program will write all the numbers inside the array. Okay, no averaging calculation here. Okay, so I am gonna delete every single thing here. I'm gonna keep the vector because it's gonna be the same. Again, I think I need an integer for a temporary integer. Then I'm gonna say stdcin. I will be reading the first value. While TMP is greater than or equal to 0, now go inside. If the initial number is a positive or a number or a 0, then int array dot pushback the value of TMP. Then read the next value to TMP. He will jump back here, and then he will be comparing the value again to check if it is a negative number or not. If it is not a negative number, he will continue doing the same thing. When he finds a negative number, then he will get out of the for loop. Here I just want to say for int I equals 0, I less than again int array dot size. Okay, here I have to use size because I don't know how many numbers I have read now. I don't have a magical int n here in this scenario. Therefore, it is mandatory to use it. Then I can say something like the ith element of the vector is int array dot just int array square bracket I std and l. All right. So some numbers 67, 89, 456, 60, minus 5. All right. So when I hit enter after minus 5, the program is finished because it's a negative number. You see that the 0th element is again like be careful. This is 0th element. Again, like in the regular arrays. That's good. So 0th element is 67. Well, that's good or that's bad, depending on what kind of. If you don't like these things, that is still horrible. But this is C++. Come on, you have to be very careful about that. Arrays, all of those things. In many programming languages, don't get me wrong, the first element is actually the 0th element. 67, 89, 456, 60. Minus 5 is not there because it is not included. It's not supposed to be included. Okay. All right. At this moment, you might have a little bit of a question in your mind saying like, why this is called this kind of a data structure is called a vector? Because we kind of know something like with the name vector from math, from geometry, or in general math, but this is not actually a vector. I mean, you can scratch the concept of vector and then you can come up with such a data structure, but it is really a stretch. And it is even then, I think, a bit of a problematic thing. I'm not super knowledgeable about the full mathematical definition of vector. I know it, I think, partially from an engineering point of view, but still it feels weird. For example, the equivalent data structure in Java is called an array list. So why not call this thing an array list? Well, a good quote from Björn Strustrup, the main guy of the C++ language, goes like this. So he says that in the main C++ programming language book, so the val array, there's another data structure called val array. It should have been actually called a vector because it is a traditional vector. And that vector, this vector I have been talking about, should have been called array. However, that is not how the terminology have evolved. Okay, so apparently this is kind of a misnomer here. And the blame doesn't go to Björn Strustrup, by the way. If you're interested, check out the how the STL, the standard template library, has been built up, because there's another author of the STL. And even that guy has made a bit of either a mistake or it's a bit of an interesting story. I will be putting the link to that discussion there, and he's saying like, okay, I think I've made a mistake. So long story short, the name is kind of a misnomer, but this is what it is, and this is something that you will be using a lot. It's a very powerful container, super powerful and flexible container. The name is a misnomer. Okay, no big deal. All right. So there are a couple of other alternative initialization codes available for us for initialization of the vectors. Okay, so the first one is something that we have already seen, initially empty vector. You don't write down anything next to the name, and it just basically starts from no elements. A second one, if you just provide them within parentheses a number, then you're actually initializing a vector with an initial size. In this case, initial size of 5. Another option is something like this. Within parentheses, you write down two numbers, 5, 10. Here, you are having a vector of size 5, and all the items have the same value of 10. Next is a more sophisticated one, and I think you can really guess that what is going on, because it is very similar to the, again, array notation. Within curly bracket couples, you just write down all the items, and 3 is going to be the 0th item, 4 is going to be the first item, and so on and so forth. One last thing is, let's assume you have a vector called vect1, having 5 elements like this. And then you want to make a copy from this vector, what I will be calling copying from vect1. So this is a copy. So I want this second vector to have all the values of the first vector. I can write something like this. Within the parentheses, vect1.begin, vect1.end. Okay, what are these things? Because we haven't seen these things. This seems like it. I think it is clear from the names, from the beginning to the end of the vector. Just take all the items starting from the beginning and to the end. But this, what is this thing? Okay, these things are connected to what I will be calling an iterator. Iterator is again something defined in the STL, the standard template library. All container classes like the vectors or the linked lists, maps, trees, there are many containers. But I will be only covering the vectors because other ones are generally more suitable for data structures and algorithms course. All containers in C++ have a corresponding iterator that is basically used to iterate over all the data items within the container. If you want to just go over all the items within the vector. In a sense, if you assume that a regular array is a container, but be careful, a regular array is not a container from a C++ syntax, but let's assume that it is, an iterator of the container is gonna be a classical pointer. When you say like start ptr equals ampersand regular array 0, then ptr is having the address of the 0th element of the array. Then if you say ptr++, then you're actually referring to the first element of the regular array. If you again say ptr++, then you are referring to the second element, and so on and so forth. In the same sense, if you have a int vector called av, you have an iterator called of class std : vector int : iterator vptr. So this is a vector. This is an iterator of over an integer vector. But how am I gonna make a connection between these vptr and av? Because I didn't do such a thing. For that purposes, the vector class gives us two very important functions: the av.begin and the av.end. So av.begin basically returns the address of the 0th item of the vector, and av.end is gonna give you return back the address of the last element of the vector. So they're actually returning back an address value. So what I can do is, if I write something like this, and imagine that you have a little bit of a vector as shown here, and if I say vptr equals av.begin, now actually vptr is, if you say star vptr, it's gonna give you the value 6, and vptr as a pointer, as an iterator, is pointing at the 0th element. Afterwards, if you say vptr++, now he will be referring to the first item of the vector. And if you again say star vptr, the value is going to be 8. If I say it one more time, then it's going to go over the second item. Then if I finally say av.end, then he will immediately gonna go to the last item of the vector, whatever the value of that thing. If it is a 150 element size array vector, it doesn't matter. He will go to the last item's address. As you can see from here, or as you might be guessing, all the addresses are actually one after the another within a vector. So av1's address is next to the av0's address, av2's address is next to the av1's address. So they are like a block of memory, like a subsequent memory blocks are allocated for the same vector. If I want to go over all the items in a different sense, what I can write is something like this: for vptr equals av.begin, vptr less than av.end, and vptr++. And I only have to do something like std code star vptr. Now I'm making sure that I am never gonna refer to an item which is outside of the array, outside of the vector. Because if I use the regular square brackets, I cannot be certain that if I'm really accessing an item that is already there. Because unlike Java, if you say like av8, and if av8 doesn't exist, Java will immediately give you array index out of bounds exception, a very specific error, saying like no, there is no such thing as the 8th element. In C++, no, C++ will not give you such an error. Here, you can practically guarantee that you cannot go over the size limit utilizing this kind of an iterator. And this is very nice, honestly speaking. Okay, again, the first program that we have written, let's try to rewrite it, but this time let's use an iterator. Write a program that is an integer n, reads that many integers, put them inside an int vector, and calculate average of these vectors over the vector using an iterator. Okay, a bit, again, something simple, but let's go and show it using the code. Again, I will be needing this int n, I will be needing this int CMP, I think I will be needing another double average equals 0.0. Then I am gonna open up a int vector iterator. Let's say, I don't know, aptr. Okay. stdcin n for I equals 0, I, oh, what is I? He doesn't know what I is. Then I'm gonna put it inside the array. Oh, how am I gonna do that? Int array dot pushback tmp. Then after that, I'm gonna say aptr equals, or even I don't want to have to say it here. Within the for loop, I can say like aptr equals int array dot begin, ptr less than int array dot end and aptr plus plus. Then I'm gonna say average equals average plus star aptr. Finally, same code, average equals average divided by int array dot end. Oh, not size. Sorry about that. std code. And voila. All right, 6 items. 1, 2, 3, 4, 5, 6. 3, 6, 10, 15, 21 divided by 6, 21, 7 to 3.5. Yeah. Same program, but now I didn't utilize this square bracket classical array notation, but instead I just used an iterator of the integer vector. And there's some other this kind of av.begin, av.end structures in the vectors, and some interesting thing is called there's also something called av.rbegin. This is a reverse begin. So this is if you want to iterate from the big end till the beginning. If you just say like rbegin, he's gonna say like I think reverse begin. He's gonna refer to the last item of the array. And then if you want to say like av.rend, then he's gonna refer to the 0th element of the array. Well, if you want to use it, use it. I don't know. I just don't feel like. I think from my point of view, I would prefer to use like av.begin or av.end and then go like minus minus and then go all the way down to av.begin. But whatever. We mentioned that the pushback and the popback are not the only functions that allow you to add and remove things out of a vector. The two alternatives and more generic or more flexible alternatives are this the insert function and the erase function. So assume that we have such a vector having 10 elements at the beginning, and then we have an iterator called this vptr, which is initially referring to the av.begin. If I say av.insert within parentheses vptr plus 3, 23, this means I would like to insert another integer value of 23 at the third position of the vector. So 0, 1, 2, 3. But then you are saying like there was already the third item, fourth item, fifth item, and so on within the vector. So what's going to happen to those things? All of these things will be shifted right. So the previously third item will become the fourth, previously fourth will become the fifth, and so on and so forth. Therefore, the size of the vector will be increased to 11 at the end of this insert function. In reverse, if you just say av.erase vptr plus 2, then this means I would like to delete the item that is in the second position of the vector. When you say that, then there's going to be a shift left operation will be conducted over the vector. So which means is that the third item, the previously third item will become the new second item, previously fourth item will become the third item, and so on, and the size of the array will be decreased by 1. As you can see, both of them are actually utilizing the iterators. You have to give them like an iterator. You can of course gonna say it's something like av.insert within parentheses av.begin plus 3 kind of. You can just refer to them utilizing a temporary iterator items. But this is also the more common usage. Okay, one example with these iterators using this insert and the erase in particular. So here he says, write a program that reads int values until a number greater than 10,000 is entered, and the program is supposed to put all the items inside an int vector. Next, the program should go over all the values of the vector and delete the negative valued items. And finally, it should print out the values of the vector. Okay. I am gonna delete many things here. Again, I don't think the n is useful here. The average is completely meaningless here, but the TMP is gonna be useful. There's gonna be a my vector, and there's gonna be an iterator to the integer vector. Okay, so again, I'm just getting an item inside this TMP, and then I'm saying while TMP is less than or equal to, this question says equal to is also fine. If that is the case, then I want to say something like std vector, int array. Let me still use the pushback function here. I can use the insert function, but yeah, let's use the pushback function for the time being. Then I'm just gonna copy and paste this line. So I'd like to read the next item of the sequence. Then what I'm gonna do is for aptr equals int array dot begin, whoops, then aptr less than int array dot end and aptr plus plus, right? So if star aptr, the item that is referred to by the iterator at that moment, is less than 0, which means this is a negative number, the negative valued item. In this case, what I want you to do is int array dot erase aptr, I guess, something like this, I guess. Then at the end of the function, at the end of the for loop, I'd like to do the same thing, and I'd like to write down all the items within the array. Again, by doing like this, but instead of having an if clause, I don't want to have an if clause round, because all I have to do is writing down all the items. But let's go a little bit more cosmetic here. I just want to say something like this. I think star aptr, then something like this, and at the end std quote, std and l. I just like to copy this part here too, so I just want to see like what is happening here. How does my items are being changed? Okay. So I'm gonna give a sequence of numbers. One of the elements will be a negative number, and the final one is gonna be something bigger than 10,000, which is gonna be like a terminator of the sequence. Okay, 56, 7, 3, 28 minus 2, 94. In this case, as you can see, 56, like it started with the regular old items within the vector, and then after this little for loop, that array that checks if some value is negative, and then he's gonna erase that number using the erase function. As you can see, minus 2 is gone. But let me run this code one more time with an input where there's a consecutive minus values here. Okay, as you can see, there's a bit of a problem going on here, because the second negative value is not deleted. What is the problem here, I wonder? So the thing is, if you start from aptr equals int array.begin, he's now referring to this item, right? And then he continues 7, 5, minus 5. If it is minus 5, he's just saying I am just deleting it. But then be careful, he's still looking at the 0, 1, 2, third item, right? He's looking at the third item. But now after this erase operation, the third item immediately becomes -6. But since I am not decreasing the value of APTR after this erase, what I'm doing is I'm just increasing the value of the APTR as normal. Then I'm gonna completely skip over this item now. This new third item is gonna be completely omitted. So in order to fix this problem, I'm gonna say here APTR minus minus. And let me run the program with the same input this time. As you can see, the -6 is also gone. Because now, after deleting the -5, I revert back to this item. And then because of this APTR++, I immediately go to the new 1, 0, 1, 2, 3 item, which is normally it's gonna be -6. So I will check it this time, the new third item. In case it is a negative number, I will do the erasure operation one more time. And then all the items after the -6 will be shifted to the left again. And this will keep continuing until I either reach the end of the vector or there is no negative numbers within the vector anymore. There's another question here, which is a bit more sophisticated version of the previous one I have solved. Here was, I think this is gonna be a good exercise, but I think I'm gonna leave it to you to code and try. This is a program which reads character values until a percent character is entered. And now you have to use a character vector. Next, the program should go over all the values of the vector. First of all, it has to replace the lowercase values with their uppercase equivalents. And then you have to delete the items which have digit values from 0 to 9. And finally, it's supposed to print out the values of the vector. So I think it's going to be a good example, but I'm not going to go into the details and I'm not going to solve this one. All right? Okay. So far, we have been using the vectors with primitive classes like the integer, character, double, float, this kind of stuff, boolean. Okay, that's one way of doing things. And in some cases, and actually in many cases, you will like to use the vector for classes because this is a much more flexible array structure, and we also want to have arrays of classes, obviously. This is possible, don't get me wrong, but in some cases you can have a bit of an interesting thing, so I just like to go over these cases and try to explain what is going on here, because there are some, I don't want to say changes, but like the objects with the vectors might behave differently from time to time. Especially how the constructors are called, how the destructors are called, could be as something that you are not honestly, I can't say weird. Yeah, it's not wrong, don't get me wrong. It's just like you may not have expect how they work. In the first example, I can just open up a tank class, a tank array, an array of tank class that we have worked on in the previous weeks. But again, the first one is an empty vector. The second one is gonna start with 5 tank items. All of them are gonna be initialized somehow. We'll see very fast. Okay, so first of all, just before continuing, I'd like to make a little modification to the tank class. I'd like to add one more protected field, which is called speed. And I'd like to modify the one parameter constructor so that it takes one more argument, again that is called speed, and assign its value to the local field speed. Modify the default constructor so that it assigns 0 to speed. The cout function, all 3 constructors, the one parameter, default, and the copy, all of these couts should also print out the speed field. And similarly, the destructor should also print out the speed field as well. Okay, some little cleaning up before continuing. Okay, these things are unnecessary, so I'm completely removing them. And I'm just going inside my tank class. Here, I'm adding one more protected field called speed. This one, formerly one parameter constructor. Now I think I have to also change the name to 2 parameter constructor, right? So int armor, comma, int speed, armor rating, comma, speed. Oh. This is gonna be a 2 parameter constructor. Armor rating is this, Then I'm gonna say speed is, maybe I can say it like this, speed is speed. So I'm gonna copy and paste it in here, but instead of 2-parameter constructor, I'm gonna say this is a default constructor. Same work, whoops, same work in the copy constructor. Instead of saying 2-parameter copy constructor, here destructed tank object armor rating is blah blah. Then I think this would be suitable. Yeah. Okay. Just for testing purposes, I just want to have something like, again, a 5th division, oh sorry, tank, 5th division, tank 20, 20, the 30, 20. I just want to check like everything is fine. Okay, yep, everything seems fine. All right, so let's go over a couple of vector initializations with these kind of vectors of classes. So let's say I have such a vector. What's gonna happen? Let's check it out. std vector tank, a tank array, an empty vector of tanks. std colon vector, tank array. Okay, none of the constructors, neither the constructors nor the destructor is called because you are not assigning any item here. This is just an empty vector right now. Let's do it like this now. Now I'm opening up a tank vector having 5 items. Okay, so this thing is a bit strange. So here I am actually opening up 5 objects and all of them are utilizing the default constructor. And at the end, since they have been allocated, and as you remember, these items are all gonna be allocated in the stack. Therefore, at the end of this this block, at the end of the main function, they are gonna be destructed. They are gonna be destroyed. Why the first one is giving a weird value? I think you can just play around with that and try to understand what is going on there. Or maybe I'm making a little bit of a mistake here. Yes, apparently I'm making a little bit of a mistake here. Because I completely forgotten about writing down this here. Aha. Yeah, now this is also fixed. So here, as you can see, if you open up with a fixed size, C++ immediately puts item objects to the vector, but all of these objects we're gonna call the default constructor. Okay, next one. If I write something like this, what's gonna happen? So as you can see, I'm giving him a particular tank object, right? Tank 20, 10. So I'm trying to, most likely, he's gonna just open up this array of size 5, this vector of size 5, and he's gonna just have these tank objects whose armor rating is 20, speed value is 10, 5 of them. That's what I'm guessing. Tank with lowercase t here. And let me run it now. Okay, speed is again a bit weird. What is going on? Maybe most likely I've made a mistake there. Huh. Interesting. Huh. This is not what I have expected. The first one is actually calling the 2-parameter constructor, which is here. But the other ones are using the copy constructor. Huh. And the copy constructor is actually, we have forgotten to make something like this here, right? Hence the problem. So first of all, let's fix this issue. All right. So that's interesting. So he's actually opening up one of these, the first item, with the regular 2-parameter constructor because we are really giving him 2 items. But for the rest of them, for the other 4 items, he's using the copy constructor. That's interesting. That's even, well, even a bit weirder. I'm seeing 5 items here, right? Huh. That's even weirder. How many destructors there are? 6 of them. Okay, let me put a little bit of a code here to see that when these destructors are being called. The end of the program, let's say. Because since... Alright, so this is doing something very, very interesting here. So he's opening up an item, okay? And then he's making a copy out of this thing, but 5 copies, and puts all of these copies inside the vector. And then he realized that this is not necessary anymore. So apparently, when I write it like this, tank 20, 10, I'm opening up a temporary tank variable. And a temporary tank variable is going to be using, based on the number of items that you are passing him, the 2-point constructor in this particular example. But then when the vector initialization has been finished, this item, this temporary item, is no longer needed, so it is, as you can see, being destroyed. That is something very interesting. Alright, one more item. If I do something like this, now I'm not specifying the size of the vector, as you can see, but I'm just giving him 2 items with different values, different armor rating, different speed values. Alright. So I'm deleting this 5, tank 2010, 2010, 30, 40, right? 40, 30. But instead of using the regular parentheses, I'm supposed to, whoop, he just finished it up, but improperly he finished it up. All right. So let's see what's gonna happen here. Alright, the same behavior continues, as you can see. So he has initialized 2 objects. He have instantiated 2 objects which are using the 2-parameter constructor, but they are actually temporary objects. Then he used the copy constructor to copy the first one within the vector, and again do the same thing for the second item of the vector. Then he realized that these are temporary things, so he just called the destructors. As you can see, the constructors are not like this kind of initialization may not be working as you have imagined, because this part seems weird, right? You might be thinking like he only used these 2-parameter constructors and these things are completely nonsense. But as you can see, this behaves differently. All right. How am I gonna use the pushback function? Let me use the pushback function again. And because I can do that, and just as you can see, the notation is a little bit different, because in the integer case I was just writing down 23, but here I am specifying that this is a tank object. So again, here after this initialization, let's continue from, or maybe let's not complicate things. Let's have an empty vector, and then I'm gonna say tank array dot pushback tank. What was the values? 45, 50. And then see what is going on here. Alright, the same behavior, we can see that. Again, a temporary object is being created using the 2-parameter constructor. Then that item is being copied by the copy constructor within the to another location within the vector. This temporary object is now being destroyed. At the end of the program, the actual item within the actual object within the vector is now destroyed. So this is a bit different. So, well, I mean, yeah, we are a bit confused, I can say that, but this is a bit of an interesting idea. But you might be guessing, like in the previous example, this might be okay. But like if we keep doing such things, because we will be adding more items to our vector. So in every single one of these pushbacks, if I am utilizing like a temporary object and then just calling its constructor and then calling its destructor, it's gonna be a very tiresome, very unnecessary work. So do we have an alternative here? So let's check it out again in a more memory-centric point of view. How this thing works, this pushback works when he's working with as a vector of classes. So imagine that you start here with 4 items, but they are like empty, and these 0x 13 45 50 things are the addresses of every single one of these things. I just put them like 10 bytes of size, every single one of them. This 16 bytes of memory for every one of them. It's not important, I just made that number up. So when you say pushback, he is actually initializing it as a temporary object somewhere, because of this two parameter constructor. Then this thing is being copied within the array. Then this new temporary thing is no longer needed. That thing is destroyed. This is basically what happens when you just write down such a function, dot pushback within parentheses tank 45, 50. So we have an alternative function called inplaceback. That is a bit gonna act a bit more efficiently here, because this inplaceback, as you might be seeing from notation too, I have deleted this tank within parentheses 45, 50, and I just write down 45, 50. So here the inplaceback function behaves in many senses like the pushback, but the main difference is he's gonna initialize the object directly within the vector. So if I change my code, here, and it's gonna say inplaceback, and in this scenario, as you can see, I can still use the older notation, but if I use the older notation, still he's gonna call the two parameter constructor, so the same problem is still here. But with the inplaceback, you can now directly put an item within the vector. No copying, nothing. And as you might be imagining, this is gonna be more efficient because you are not, I mean, these are simple. This tank class is a very simple class, so it may not be very problematic here, because it's gonna be very fast operation to open up just initializing two integer values. But if you just if you are working with a very big class, then this temporary object being created and destroyed is gonna be a potential efficiency problem. Yep. Yeah. Okay, so this is what we have already done. So let's do it one more time. Try to add a second tank object with the inplaceback and observe the calls to constructor and destructor. Okay, so we have kind of learned our lesson. So we are seeing that the inplaceback is solving all of our problems. Let's try it again with another. I'm just changing the values because of the otherwise it's gonna be very difficult to understand which destructor is belonging to which one of these things, right? So I'm not gonna see a copy constructor call. No, wait, what? All right, I'm seeing a copy constructor call. So I'm seeing something like this. Okay, again, I am unable to get rid of this copy constructor stuff. Alright, damn it. Okay, what is going on here? Because I was saying like this is directly adding the object within the vector. What the hell is going on here? So there's actually a bit something called a vector resizing I have to talk about right now. How does, because I mentioned that in the start of lecture, I said that the vectors are automatically increasing their sizes. When you are pushing more items within the vector, they know how to increase their sizes. But how do they do that? Because we didn't cover it. So after this first call, inplaceback 45, 50, this part. So this is how it looks like. Then you just write down the second item, the 55, 30. Oh, yeah, the numbers are different. So C++ is saying like the tank array, this vector, doesn't have any second place. So what should I do? How am I gonna put it there? Because there is no such place. So what he says is, let me open up a new memory space for 2 items. And as you can see from the addresses, they are different places. It is not the next block here, right? The addresses are completely different. It could be different, it could be the same, by the way, don't get me wrong, but most likely it's gonna be different addresses. So he opens up a new memory for 2 spaces, and then he's gonna copy this new item. He's gonna directly put the new item to the second element, the first element, and he's gonna copy the 0th element here, and then he's gonna destroy the other one, the older one. Confused? So here, he's just using a 2-parameter constructor, right? For the next, initially, for this item, he's using the 2-parameter constructor. Then, when you come to this line, he realizes that he needs another memory space. And he immediately opens up a memory space for 2 tank objects. And he immediately calls the 2-parameter constructor and opens up an object at the first element of the first position of the newly allocated vector space. So this part is done. Then he's supposed to copy the 0th element here, hence the copy constructor. But then this the older guy with the older address is no longer necessary because it is completely redundant. He shouldn't be using that memory space for his purposes now. It is completely unnecessary now. So he's gonna call the destructor of the former memory space of the vector. Okay, that is a very interesting thing. Like the vectors, how they are resizing. This is what they do. When they run out of space, they immediately allocate another memory space in another part of the stack, in this case, because all of these variables are, be careful, they are in the stack because they are all local variables. We will come to the heap allocated vectors next week. All right, let's continue doing things. Let's add more tank objects and try to observe how does the standard template library gradually increase the size of the vector. Because again, that part might be a bit confusing. Let me do it one more time. So every single time I'm going to increase the arm rating by 10 and I'm going to decrease the speed by 10. Okay, the third item. So this is the first item. In the second item, he is increasing the size, right? And he's destroying the other one. In the third one, as you can see, he is opening up a third item and he's copying the first and the second items. And he's again destroying the older 2 space memory block. All right, so this is fine. One more time. 75, 20. So I'm expecting something like 2-parameter, 2-parameter copy, 2-parameter copy, 2-parameter copy, but no. Again, this is again working a little bit different than we have anticipated, right? Again, he's just messing around with that, I think. Messing around with us. All right. In order to understand what is going on here, I have to introduce one more function here, capacity. So this capacity is, be careful, this is not the size. Capacity is the number of available item slots in the vector. But the size is the number of actual items within the vector. Okay, what do I mean by that? So let me write down before and after every single one of these in place packs 2 things. std quote size, the first one is size, tank array dot size. Then I'm gonna say capacity, so how many items you can put inside. The first one is how many items that are actually there, capacity. All right. And at the end of every single one of them. Alright, in the beginning, size is 0, capacity is 0, as normal. Then I am trying to add my first item using the inplaceback. Since inplaceback directly allocates within the vector, he just says the capacity is 0, so he just calls the compiler, most likely is gonna call the operating system, can you allocate me one tank sized memory space within the stack? He's gonna say sure, use this memory space. Now he has the vector has a size of 1, but at the same time has a capacity of 1. So when you call the second one, the inplaceback 55, 40, this one capacity, one size, so he's using the 100% of the capacity, right? There's only one capacity and there's actually one item, so it's completely full. So he needs another memory space, and he just calls it. He just increased the size, the capacity to 2, and of course increase the size to 2. So far that's fine. When you are calling down this third one, things start to become a bit weird. The inplaceback 65, 30. So this capacity 2 is not enough because I want to add the third item here, but then he asks for more memory space. But as you can see here, he's not asking for a capacity of 3. He's asking for a capacity of 4. So he started by saying like +1, +1, +2 now. So he's just gonna think that, okay, at this rate, the user most likely is gonna be adding one more item. So before he or she is gonna ask for one more item, and I have to do all this resizing stuff one more time, let me just get ahead of the programmer and then say like, okay, let me allocate 2 spaces so that he can accommodate, the vector can accommodate one more item before resizing, because resizing takes time, takes computation time. Memory space takes, well, memory space, RAM. So there's always a trade-off here. The more you allocate, the more memory you are using, but you don't need to resize every single time. But then the less memory space you use, the more number of resizing operation you have to do, which takes time. So there's always a trade-off. How should you increase it? By like 1, 2, 4, then maybe 8, I think. I'm not 100% sure how STL works, but most likely if you try to add one more item, but yeah, let's do that. Why not? Since we have a compiler in front of us. Let's go like this. And let's see how it's gonna be. Yes, as you can see, now the capacity has been increased to 8. So I think he's either going to the powers of 2 or always multiplying it by 2. Well, sorry, that's goes to the same result. So 2 to the power 0, 2 to the power 1, 2 to the power 2 to the power 0, 2 to the power 1, 2, and 3. So, but be careful. This might be the STL implementation in my particular. I'm using MinGW. Maybe the MinGW's STL is utilizing it like this. Maybe other STLs, if you are compiling it in GCC, maybe they just gradually increase it. I'm not 100% sure. But as you can see, this is trying to be a little bit smarter here. Hence, these confusing problems that we are seeing. But in a sense, honestly, he's trying to do something very nice. But we have to understand what is going on here. Now, different C++ compilers may have their own ways of doing these kind of stuff. One function that is going to be crucial for when we understand this capacity, we can actually force C++, the STL library, to reserve space before allocating things. Because if you say tank array 5, so let me comment these things. Let me comment these things out and say that this is 5 or maybe 10. So now, as we have seen previously, he's gonna open up 10 objects, right? But they are not gonna be useful. So again, we are actually losing efficiency. This is unnecessary stuff. These things we are not gonna be using. So instead, what I can do is I can say, dear operating system, can you reserve me 10 items here, because I am gonna be adding several items afterwards. So now, as you can see, in the beginning, the capacity is 10 now, because I said it so with the reserve function. And every single time there is no copying whatsoever. So no temporary bye-bye to the temporary objects, and bye-bye to copy constructor calls and destructor calls. But our cost here is we are now allocating unnecessary memory capacity. So it completely depends on what you are trying to do. If you are really trying to add something, like add a lot of items, if you know that on average you're gonna be adding a lot of items, reserving beforehand is a very, very good choice. But if you are not sure how many items you're gonna be getting from the user based on what your program is trying to do, honestly, then reserving is gonna be costing a lot of unnecessary memory usage. So it's always an efficiency between, in computer science, always an efficiency between memory space versus I think what was the name? Capacity complexity versus computational complexity. Maybe I'm just using capacity complex might be not a very good wording, but I think you got the idea. Okay, last couple of things. I can still use the insert function with the objects, but then if I try to use the insert function, it will exactly work like the pushback. So he's gonna make a temporary object somewhere and then copy it inside the vector. Instead, I also have this emplace function, which directly makes an object within the vector. And as you can see, I will just write down all the arguments of the parameter. I'm not writing down tank within parentheses here, both in the emplace and in the emplace back. I just write down directly the items that the constructor is expecting from me. Okay? So be careful about that. Both functions shift the objects to the right before adding the new item. So in that sense, they act the same. However, temporary objecting is completely removed in emplace. So if you are unless you have a particular reason for doing a temporary object, I suggest you to use emplace. Emplace is added in C++ 11, if I'm not mistaken. Check it out. So, yeah, this is also a little bit of an example. If I have this reserve function with 5, and then I'm just gonna insert something, the 5th division tank. Let's go over this example and see how it's gonna happen. I mean, well, maybe I shouldn't be going to C line this time, because here he's gonna be using the copy constructor. This is something different. We are inserting an already existing item, right? Because a 5th division tank object is already an object. So what I'm trying to do is I'm inserting that object, but be careful, I am not actually inserting that object. I am inserting a copy of the 5th division tank object. So if I make a change in 5th division square bracket 0, then it's not gonna make any changes in the actual 5th division tank object. Be careful. These are two different variables. In the second line, in the insert with the tank 35, 50, it's gonna work as we have already discussed. He's gonna open it up in somewhere, and then he's gonna copy it to the vector, and then he's gonna call the destructor for the temporary object. But the emplace is gonna work as we have again talked about. He's gonna directly open up the object within the vector. Sorry about this one parameter constructor notations here. It should be saying 2. Alright, so that is it for this part. So we have covered a lot about the vectors, both for primitive data types, and we have seen how they act a little bit differently for the objects. I don't want to say differently, but they are kind of, and we don't honestly need the emplace. You still can use the emplace and emplace back and emplace functions for the primitives. If you only have an integer vector, double vector, you can still use the emplace and the emplace back. but you might argue that they are not that necessary there. But in terms of objects, yes, they're gonna be necessary in terms of efficiency. In order to maximize efficiency, you have to get rid of the insert and you have to get rid of the pushback. Instead, use the in-place versions. So that's gonna be it for this part. So in the next part, we'll be talking about vectors again, but then we're gonna be talking about how to open up vectors in the heap, because all the vectors that we have defined today in this part are vectors within the stack. So take care. I hope this was a good video, good explanation. Thank you for that. Thank you for listening, and see you next time. Bye-bye.